Hello friends, welcome to our channel Solution with Harmonium Learners for 2K19. In today's session, continuing with the basics of electrical engineering, here we have brought up a numerical session for you on the topic electronic velocity, resistance, current, power and resistivity. So in today's session, here we will be explaining some of the numerical problems related to how to find the current, how to find the electronic velocity and how to find the power absorbed by a given circuit whenever the certain quantities are given and the various kind of questions are faced by the candidates in the examinations. So it will be very beneficial for the first year engineering students. So let's start with our topic without wasting our time. So first question here given is a conductor material has a free electron density of 10 to the power 4 electrons per meter cube. And when a voltage is applied across a constant drift velocity of 1.5 into 10 to the power minus 2 meter per second is attained by the electrons. So if the cross section of the material is 1 centimeter square, then we have to calculate the magnitude of the current. And the electronic charge of the current, electronic charge on the single electron, as we already know, that is 1.6 into 10 to the power minus 19 coulomb. So here, first of all, note down the following quantities are given here in this question. First of all, we are given here with the electron density, that is the 10 to the power 24 electrons per meter cube. And second one is the area of the cross section, that is given as 1 centimeter square. On converting it into meter, we will get it as 10 to the power minus 4 meter square. And the charge on a single electron is 1.6 into 10 to the power minus 19 coulomb. And the drift velocity of the electron is V is equal to 1.5 into 10 to the power minus 2 meter per second. So using all these quantities, the formula that we already know, that how to find the current using the electron density, area of the cross section and the charge on the electron and the drift velocity, the formula that is used to find the amount of the current flowing through a circuit is given as N multiplied by A multiplied by E multiplied by V, where N is the electron density, A is the area of the cross section, and E denotes the amount of the charge, and V is the drift velocity, and N is the electron density, A is the area of the cross section, and E is the charge on the electron, and V is the drift velocity of the electron. So here we will substitute all the values given here in this question. Electron density is given as 10 to the power 24, so we substitute that. Area on converting into meter, we get it as 10 to the power minus 4, that is also substituted here as, and the charge on the single electron is 1.6 into 10 to the power minus 19, and drift velocity of electron is 1.5 into 10 to the power minus 2. So on multiply all these quantities together, what we will get? 1.6 multiply 1.5. On multiplying 10 to the power 24 with 10 to the power minus 4, what we get? 10 to the power 20. And on multiply 10 to the power minus 19 with 10 to the power minus 2, what we get? On multiplying 10 to the power minus 19 with 10 to the power minus 2, we get it as 10 to the power minus 21. And on multiplying 10 to the power 24 with 10 to the power minus 4, we get 10 to the power 20. On multiplying 1.6 into 1.5, we get 10 to the power 2.40. And on multiplying 10 to the power 20 with 10 to the power minus 21, we get 10 to the power minus 1. Because on adding minus 21 with 20, what we get? 10 minus 1. So 10 to the power minus 1 will come out as 2.4 divided by 10, because on bringing it into the denominator, what we get? 2.40 divided by 10. So on dividing 2.40 by 10, what we will get the final value of the current is 0.24 ampere. What we will get the value of the current? The current value obtained will be 0.24 ampere. So the amount of the current flowing through the circuit is comes out to be equals to. So the amount of the current flowing through a circuit comes out to be equals to 0.24 ampere. So it is our final answer. So friends, let's move on to our next question. Next question given here is as follows. Find the velocity of the charge leading to 1 ampere current which flows in a copper conductor of cross section of 1 centimeter square and length 10 kilometer. Free electron density of copper is equal to 8.5 into 10 to the power 28 per meter cube. How long will it take electric charge to travel from one end of the conductor to the other? So first of all, note down what are the quantities given here in this question. First of all, given is here is the the quantity that is given here is the current is flowing through a circuit is 1 ampere. What quantity of current is flowing through the circuit? 1 ampere. And what is the area of cross section of the copper conductor? Area of cross section given here is 1 centimeter square. On converting it into meter, what will get 10 to the minus 4 meter. And the length of the conductor is given as 10 kilometer. What is the length of the conductor given? Length of the conductor is given as 10 kilometer. Means on converting it into meter, what we will get? 1 kilometer is equals to 1000 meter. So we will get it as 10 to the power 4 meter. Length for what will be the length of the conductor? 10 to the power 4 meters. That is clear. And now here the electron density is also given. Electron density is given as 8.5 into 10 to the power 8 electrons per meter cube. So first of all, we will find out the velocity of the drift velocity of the electron using the formula V is equals to I divided by NEA. How we will calculate it? V is equals to I divided by N multiplied by E multiplied by A. I is the charge, I is the current flowing through the circuit, N is the electron density, and E is the amount of the charge flowing through the circuit, and A is the area of cross section of the conductor. So here 4 quantities we already know. I is the current, A is the area of cross section given here as 10 to the power minus 4 meters square, and E is the charge on the electron, that is 1.6 into 10 to the power minus 19 coulomb, and N is the electron density of the electron. N is the electron density of the electron, that is 8.5 into 10 to the power 28 electrons per meter. So on substituting all these values, what we will get? V is equals to 1 divided by 8.5 into 10 to the power 28 multiplied by 1.6 multiplied by 10 to the power minus 19 into 10 to the power minus 4. It is the power 10 raised to the power minus 19. It can also be written as 10 raised to the power minus 19. It is actually the 10 raised to the power minus 19. 10 power of the 10 raised to the is minus 19. 10 raised to the power minus 19 actually it is. So on solving it, what we will get the drift velocity of the electron as V is equals to 7.535 into 10 to the power minus 7 meter per second. On converting if we want to convert it into micrometer, then we have to multiply it with the 10 to the power 6, because here our requirement is to convert it into 10 to the power here we have to convert it into the smallest form, so we have multiplied it with 10 to the power 6. So our velocity of the electron, drift velocity of the electron comes out to be 0.735 micrometer per second. So we have here got the drift velocity of the electron. Now we have to find out the time taken by the charge to travel from the conductor of the length of 10 kilometers. How we will find out the time? Let's see. So time, we basically know that the time formula for calculating the time is equal to distance upon velocity, and we already know that what is the length of the conductor given? 10 to the power 4 meter, means 10 kilometer was given. So multiplying it with the 10 to the power 3 or converting it into meter, what we will get the velocity of the time is 10 to the power 4. Distance, what we will get? 10 to the power 4 meter. That will be divided by the velocity obtained here, that is 7.35 into 10 to the power minus 7 meter per second. On dividing the total distance 10 to the power 4 by 7.35 into 10 to the power minus second, what we will get? So we will get the value of the time as 1.36 into 10 to the power 10 seconds. This is the total amount of the time taken. So and 1 year, as we already know that now we have to convert it into year. How we will convert? We already know that 1 year contains 365 days, 1 day has 24 hours, 1 hour has 60 minutes, and 1 minute is equal to 60 minutes. Total 31 million 536,000 seconds will come out to be here. As we can see here, that's how we will calculate that how many billion seconds these are: 1, 10, 100, 1000, 10,000, lakh, and lakh crore. So 3 crore, 31 crore, 53 lakh 6,000 seconds. This is the total amount of the second. So on dividing the time obtained here, 1.36 into 10 to the power 6 by 31, 536, 000, what we will get the total amount of the time taken by the charge to travel the length of the 1 kilometer with the drift velocity of 7.35 into 10 to the power minus second will be 431. If the charge is traveling with the drift velocity, or charge is getting drifted with the drift velocity of 7.35 into 10 is to power minus 7 meter per second. If the charge is traveling with a drift velocity of 7.35 into 10 to power minus 7 meter per second, then the total amount of the time taken to travel the length of 10 to power 4 kilometer will be 10 to power 4 meter will be equals to 431 years. So here is our answer that the total amount of the time taken will be equals to 431 years. So now let's move on to our next question. Next question is, a coil consists of 2000 turns of a copper wire having a cross-sectional area of 0.8 meter square mm square. The mean length per turn is 80 centimeter, and the resistivity of the copper is 0.02 micrometer. Find the resistance of the coil and power absorbed by the coil when connected across 110 volt DC supply. First of all, let's see what are given in here in the question. A coil consists of 2000 turns of copper. How many turns are present in a copper wire? 2000 turns. And length of one turn is given as 80 centimeters. So let's convert it into meter. So for converting it into meter, we divide it by 100. So our length obtained is 0.8 meter. And for calculating the total length of the coil, what we will get? 80 divided by 100 multiplied by 2000. So our total length comes out to be equals to 1600 meter. And how to find out the area of the cross section? What area of cross section given is 0.8 meter square. Now we have to convert it into meter, and we already know that 1 mm is equals to 10 is to power minus 3 meter. What is the value of the 1 mm? Value of 1 mm is equals to 10 is to power minus 3 meter. 10 is to power minus 3 meter. What is the value of 1 mm? 1 mm is equals to 10 to the power minus 3 meter. So on multiplying 10 to the power minus 3 two times, what we will get? 0.8 multiplied by 10 to the power minus 6. Because on multiplying 10 to the power minus 3 two times, because it is the area. So here we will multiply 10 to the power minus 3 two times. What we will get finally? 10 to the power minus 6. So we will multiply 10 to the power minus 6 with 0.8. And what will be the area obtained in meters? So 0.8 into 10 to the power minus 6 meter square. Now we will calculate the resistance using the specific resistivity, length of the conductor and area of cross section. So here the specific resistivity of the copper wire that is given here is 0.02 into 10 to the power minus 6 meter, 10 to the power minus 6 is the resistivity. 1600 is the length of the total copper wire, and area of the cross section is equal to 0.8 into 10 to the power minus 6. What is the total length of the copper wire? Total length is for 1600 meter. Specific resistivity is 0.8 into 10 to the power minus 6, 0.02 into 10 to the power minus 6, and specific resistivity of the area of the cross section is 0.8 into 10 to the power minus 6 meter square. The area of cross section is 0.8 into 10 to the power minus 6 meter square. So on calculation and calculation, what we will get the value of the it as 40 meter, 40 ohm. What will be the value of the resistance? Resistance value comes out to be equals to 40 ohm. So on calculation of how to calculate the power absorbed, will be calculated by using formula V square by V. What is the potential difference applied across the two ends of this conductor? We have to find out first of all we have to obtain the value of the resistance. We have to find out the two quantities. First of all was the resistance of the conductor that we have obtained as 40 ohm, and now we have to find out the power that will be absorbed by the coil when connected across the 110 volt DC supply. Now what is the potential difference applied? Was the 110 volt. So power absorbed will be equals to 110 square by R. So for in place of V, what we will write? 110 square divided by resistance value is equals to 40 ohm. So our total power on calculating, what we get is 302.5 watt, which is the SI unit of the power. So our final answer obtained here is the power absorbed is equal to 302.5 watt. This is our final answer. Now let's move on to our next question. That in it we have to find out the diameter of a copper wire. But first of all, see what are the quantities given here. An aluminium wire 7.5 meter long is connected in parallel with the copper wire. Means it is here is given it's a parallel combination like this. Here is the aluminium wire and the copper wire, both are connected parallelly with each other, and the potential difference of V is applied across them. And we already know that, and here is the fact that potential difference applied remains same across the appliances resistors connected in parallel combinations. The potential difference either across the aluminum wire, either across the copper wire, the potential difference will remain same across both ends, both of the conductor when they are connected in parallel, and the current flowing through them gets divided when they are connected in parallel. Now we will use this fact in solving this question. So first of all, here it is given as an aluminum wire which is connected in parallel with the copper wire. Length of copper wire is 6 meters, length of aluminum wire is 7.5 meters. When a current of 5 amperes pass through the combination, it is that is found that the current in the aluminum wire is 3 ampere. Current flowing through the aluminum wire is equal to 3 ampere. Current flowing through the aluminum wire is comes out to be equal to 3 ampere, and the diameter of the aluminum wire is 1 mm. What is the diameter of aluminum wire? Diameter of aluminum wire is 1 mm. Determine the diameter of the copper wire. We have to determine the diameter of the copper wire, and resistivity of the copper is given as 0.0717 micrometer and micro ohm meter, and that of the resistivity of the aluminum is given as 0.028 micrometer. Now let's use all these in the solving the question. Now let's move towards our solution. So here first of all we guys said we can put some of the descriptive points for here that we will discriminate we will identify the aluminum as represented by subscript 1. Those all of having the written here with the subscript 1 are representing the aluminum, and subscript those written with the subscript 2 are representing the copper. So friends, here L1 length 1 is given of the L1 is the length of the copper length of the aluminum wire, that is 7.5 meter, and here it is L2 given. It is L2, that is the length of the copper wire, that is L2 is equals to 6 meter. It is the length of the copper wire. Rho 2 is the resistivity of the copper wire, that is 0.0171 micrometer, and rho 1 is the resistivity of the aluminum wire, that is 0.02 micro ohm meter. Resistance is calculated by the formula for the aluminum wire. Resistivity formula will be R1 is equal to rho L1 divided by A1, and the formula of the resistance for the second wire will be equal to R2 is equal to rho L2 upon A2. On dividing R2 by R1, what we will get? Rho 2 divided by rho 1 multiplied by L2 divided by L1 multiplied by A1 divided by A2. First of all, now we have to find out the area of the copper wire, because area of the aluminum wire is already known to us. So formula for calculating the area of the copper wire will come out to be rho 2 divided by rho 1, L2 divided by L1 multiplied by R1 divided by R2 multiplied by A1. This is the equation number 1 we have obtained here. Now, as we already know that the total amount of current flowing through a conductor is conductor given here is 5 ampere, and suppose let's I1 is the current flowing through the aluminum wire. I1 is the amount of the current flowing through the I1 is the amount of the current flowing through the aluminum wire, and I2 is the amount of the current flowing through the copper wire, and the current flowing through the aluminum wire is given as 3 ampere. Current flowing through the aluminum wire is given as 3 ampere, and the current total amount of current flowing through it is 5 ampere. So now we have to find out the value of I2. Value of I2 will come out to be equal to 5 minus 3 ampere. So amount of the current flowing through the conductor copper wire is equal to 2 ampere. And we already we have come to know about the value of the current flowing through the copper wire. Now we already know that if V is the common voltage across the parallel combination, if V is the potential difference applied, so across the aluminum and copper wire, potential difference will remain same, but the value of the both of them will be equal. So value of the potential across the aluminum wire will be, which will be equal to I1 into R1, and the potential across the copper wire will also be equal to I2 into R2. On equating both of them, what we will get? I2 divided by I1 is equal to R1 divided by R2 is equal to 2 by 3, because I2 is equal to 2 ampere and I1 is equal to 3 ampere. Value of I2 is 2 ampere. Value of I1 is 3 ampere. So R1 upon R2 will also be equals to 2 by 3. I2 upon I1 will also be equals to 2 by 3. And we already know that the area of the cross section of the now we find out the area of the cross section of the aluminum wire, which is A1. So how to find that out? A1 is equals to pi r square by 4, pi d square by 4. Diameter of the aluminum wire is given as 1 mm. So final on substituting diameter as 1. The area of the cross section of the aluminum wire comes out with pi by 4 mm square. And similarly, substituting all the values given here in the equation number 1. Equation number 1 means A2 is equals to rho 2 divided by, here we will substitute value rho 2, rho 1, L2, L1, R1, R2, A1. On substituting, what we will get? So A2 is equals to, this is the rest, here we have put all the values as follows. These are the specific resistivities of both the wires. 0.017 divided by 0.028 multiplied by pi by 4 divided by pi by 4 is the area of the cross section of aluminum wire. That was pi by 4 mm square, and the value of the length of both the conductor comes out to be 2 by 3 multiplied by 0.017 upon 0.28. These are the areas of the resistivities of the conductor, and these are the length of both the wires, 6 and 7.5. On calculating, what we will get the value of the area of the area of copper wire. Value of the area of the copper wire comes out to be 0.2544 mm square. On equating it with the pi d square by 4 equals to 0.2544 mm square, we will get the value of D2. Diameter and we will get the value of the dimension of the diameter of the copper wire as 5.569 mm, which is our final answer. So the diameter of the copper wire comes out to be equals to 0.569 mm square. Here it is also mm square. So diameter of the copper wire comes out to be equals to how many mm? 0.569 mm. So here it is our final answer. Thank you friends. One hint is here also given below, that you have to keep in mind while solving the question number 1. The potential difference applied across the appliance resistance connected in parallel combination remains same, because the potential does not get divided while they are connected in parallel, but the current flowing gets divided as I. If the two conductors are applied, then it will be divided as I1 plus I2. If the three conductors are connected in parallel, resistors are connected in parallel, then the current will be divided as I1 plus I2 plus I3. So these are all the facts, and these are all the concepts related to today's numericals discussed in today's session, related to drift velocity, related to how to find the power and how to find the area of the cross section of a given wire when connected in parallel. These were all the tangible questions that are being touched basically in the answer. You will still focus on this. Keep watching, keep learning, and if you like the video, please like it. And for any query, you can comment me in the comment box down below. Share it with your friends. And if you are not subscribed to our channel, please subscribe to our channel. Keep learning, be creative, be enthusiastic. Thank you, friends.